Hi everyone. Welcome back to another title practice and coding video. Um, so this one's going to be funny because I think it's going to involve less live coding and more coding live. What I mean is, I have some specific things in mind I want to try and accomplish, and I thought I'd film it for the edification or amusement of others. So basically, what everything I want to do has to do with the Lindenmayer systems, and specifically Lindenmayer function, which, okay, has this innocuous type, int string to string to string. And here, I'm actually just going to copy and paste an example from the official documentation because it'll be illustrative. So the point here, so this is the example. Remember that thing I said about last time about how if you see like weird typos, it's because of my keyboard. But anyway, so what's a Lindenmayer system? It's, if you're not someone who cut their teeth in like programming language theory like I did, you may or may not know what context-free grammars are. And this is kind of a generalization of context-free grammars, in that I think it's not exactly the same set of things. It's more general, but you can kind of think of them like context-free grammars. Basically, you have like symbols, and then like you know each symbol can turn into other things, and you can kind of just recursively generate like usually like infinite trees of data. And the point of the Lindenmayer function here is that this is a way of just generating a big tree of productions and then smushing it into a string, and then having that string be some like gigantic pattern like you couldn't like possibly write on your own. So in fact, why don't we just run the code from the documentation with the caveat that it's like, I didn't write this. I also didn't include the T and didn't, so that's neat. Now, but yeah. So you can see that this involves like, it's a big pattern, right? It's 500, there's 512 characters in it, the resulting string. And it's going to be a mixture of these, zeros, ones, twos, and rests, and then you feeds that into the step function in order to, it feeds that into the step function in order to get a step sequence, a very long step sequence of samples. And okay, and that slows it down a ton so that it doesn't just like blast our eardrums out here. Just hold your horses for a second. Right. So that sounds terrible, right? But that's because there's 200. There's going to be like 256 things per cycle. Some of them will be rests, but like it's running at a 256 per cycle rate. Okay. So what I want to do though is combine this with the whole like curly braces syntax from earlier. And part of what I'm going to use for this is so it's just a funny note. The reason why I first heard of this function is because Mike Hodnick, Kingdom, like asked a question in the title chat, like it might have been like last year, when I was first kind of getting into a lot of this stuff, that about like how to use this to generate patterns, and he needed to like coerce the strings to numbers, and to like a pattern of coerce it to like a pattern of numbers and blah blah blah. It was, and ever since then I was just like, this is kind of a fun little function, but I've never found really good uses for it other than things kind of like what this example here is, right? Just taking it and then slowing it down and then hoping that it's like vaguely the rhythm we want. But so what I want is to do something a little weirder, and then so I'm writing I'm gonna write a little helper function here, and it's going to involve using this other thing that's sort of in the documentation of Tidal. And there's this function that's called parse BPE, which takes a string and tries to parse it into a pattern. So the first step here is I want something that'll just take a string and then put curly braces around it as a string, and then put the percent and then a number around in it as a string, and then we parse that into a pattern. So yeah, let's see if we can define this function quick. So we've got our string, we have our number, and so we know that the last thing we want to do is parse BPE. So we put that as wrap that around the whole thing. And the next thing we want to do is, I'm not going to worry about efficiency here, strings are lists of characters. I'm doing concatenation, just sticking strings together. Is that slow? I mean, probably, but I'm not munging with the database here. I am just trying to create a pattern that's so long I'd get bored writing it. Because boy, do I get bored easily. Okay. So, I think we want something like this. We want to, yeah, I think we want something like this. We want to put the curly braces around whatever the long string is. We want to put a percent around it. And then we want to, put the number, but as a string, right? So we have to show it. All right, moment of truth. Let's hit Control Enter and see if this goes. Okay, that did. And let's just check. Let's check what type did Haskell think that was. Okay. So it says. Okay, so it gave us the super general type, something, something that could be, anything that could be shown. So it didn't necessarily recognize that should be a number. Makes sense. It doesn't know that the percent thing has to have a number at the end. In fact, side note, this is one reason why I think it would be really, really cool to do dependent types with Tidal at some point. If anybody watches this and is into that, hit me up. So, because, oh my God, I would love to work on that. But since I don't know anyone else who's interested, it's always at the bottom of my list. All right. So that being said, let's go back to creating content. So we have our polysequence function here. Okay. So in principle, let's test this out. So this should be 2 polysync. Why do I don't know. Was polysequence actually a good term for this function? Let me think about that for a second. Because because we do call it polymetric sequences. Yeah. No, that was a good name for it. Well, yes, I am rambling. That's fine now, because this is just a little informal video, and anyone watching this is probably just as much of a nerd as I am, so it's okay. So let's go to, I don't know, let's do something that should be really straightforward. Okay, that seems to work. I mean, it gave us a pattern that's plain sound, right? So, cool. And if I make this number bigger, it should go faster. Okay, so I think that works. Okay, so now, let's worry about what we want to do with Lindenmeyer. So let's do something like let pattern string and there's going to be some other complications here, but it's going to be okay. This is going to be fun. This is going to be fun. So let's say let pattern string equal. I mean, heck, we could actually just to start copy like this example, right? That'll tell us something. Yeah. Woof. The spacing. Oh, and I didn't explain the Lindenmeyer system. The Lindenmeyer function is basically a way of saying, okay, this is how many like depths of production to go, if I remember correctly. These are the production rules. A 0 becomes a 1, and then a 1, and then a series of rests. A 1 becomes a 0 and a series of rests, then a 2, then a series of rests, then a 0, etc. And the 2 becomes a 2 and a 1 and a rest. Rest expands to being more rests and 1. And then you start the process of substitution with 0. So if we do this, this should give us some kind of pattern string. Okay. I always like to check the types. Okay, pattern string. Neat. Okay, so now what we should be able to do is pstring 5, and does this work? Oh, whoops, I did something silly. It's not going to work because we actually have a pattern string. That's what step did. Okay, let that be a lesson. Clearly, I was trying to cleverly fool you by, and not that I decided to take an ill-advised shortcut from the initial plan. Okay, back to the initial plan, which instead, so we do this. Okay. And now, so now what we want to do is, okay, so this is just a string now, which is list if you're sort of new to Haskell or not much of a Haskell programmer, when it says list, like square brackets car, that means a list of characters, which is just the definition of a string in Haskell. Haskell strings, much to the chagrin of people who want to do high performance computing, Haskell strings are not like some cute, smart, like representation. They're lists, but that does make writing a lot of code very easy. So what we need is, okay, so we have this thing, and then here, let's just look at in the little console. So, okay, you can see it's that long hecking thing down here. It might be a little hard to see on your screen, but it's you can see this production. And so what we're going to do is we're going to transform that, and we're going to turn it into just a string that has the right structure we want. And that should be pretty straightforward, because what we really want to do is a map. We want to just, so in Haskell, the map function is how you take lists of things. There's map and there's fmap, and you can kind of think of it as they're the same thing modulo some ancient design decisions and backwards compatibility. But the idea here is that mapping means you take in order to convert some big structure to another big structure that has a different type inside it, so basically like containers of objects, and you map from one to the one kind of object on the inside to the other kind of object on the inside of the container. And you do that by taking a function that takes the contents of one and turns it into turns one kind of content into the other kind of content, and then you apply that to basically all the little spaces inside the container. So for lists, every element of the list. For a tree, every data carrying node on the tree. For Frogglethorpe, all the Splorn diffs inside it. That was technical terminology. No, it wasn't. But anyway, so what we have is, I'm going to just write a little auxiliary helper function. Just call it lind2, lind_num2 sound. And this is just going to be a thing. It's what's it going to do? It's going to take characters and one kind of character and turn it into another kind of character. Basically, we're mapping strings to strings, essentially, which is fine, because what we're actually going to do is we're going to say take one and then turn that to and then and then you do lind_num2 and 0, and we make that future. And 2, you send that to and you send that to I don't know, clap. All right, and we actually have to. You'll see in a second. We have to take a little rest symbol, and then we also send that to a rest. And I'm doing this in a slightly janky way because I think it's basically straightforward at the end of the day. So if we just take a look at these functions, I've defined this function. Okay. What's the type of lind_num2 sound? It's character to string. Yeah, the type down there is a little too generic. It's character to string. Neat. Okay, but if we were to do that, so if I were to say map of this, I don't need to put the parentheses there. If I say map to this, wait a second, that's going to send the characters to strings. So that's going to be a list of strings, not a list of characters anymore. Right. But this is sort of the fun thing. This is the part that's a little jank, but I think is a cute example. So, because there's plenty of functions to do things like that. I'm trying to remember what it is in. There's a bunch of different functions to do this. I'm trying to remember the name of the built-in Haskell one. It's not flatten. I think that's the Common Lisp one. But it's pretty easy, and that okay, let's talk about another functional programming concept, which is folds. So what we're going to do, you just fold over it with an append, and then you're good. So the idea there is that folding with an append means that you're taking some kind of structure like a list, and then you're doing some operation to glue all, to glue all the pieces together, more or less. And if we just do fold and append, okay, so let's just make sure that let's look at the piece string now. And oh, hey, look, kind of has the structure we want. Cool. Was this maybe a silly way to get here? I don't know. It abuses me, which is like my favorite reason to do literally anything. So now, moment of truth. Let's see if this whole shenanigan that we're getting up to here actually does something. I mean, it does. The problem is that there are so many rests in this Lendemayer system, so maybe if we change that a bit, let's just change the number of rests a little bit. Okay, let's reevaluate, then let's try making this a little so maybe it's working, but I kind of want to mess with this just a little more. Like I said, I want to try taking out more of those rests. Yeah. Wait a second. I think I just discovered a new problem. This is gonna be neat if this is gonna be neat if this doesn't work right. So that's, oh, this is great. This is a great little example. So now what we need to do is we need to so this fun debugging, right? I used to have a job doing debugging, and horrible job, horrible company, but I did discover that I like this part of it. So if you look down at the bottom, you can see what the problem is, which is that you have these darn things where it's concatenated stuff together. Now, concatenating together the rests worked okay. Like, that didn't do anything super messed up. But when it's not the rests, well, it's trying to parse that as a sample, but there's no Kapfucherson sample, right? So actually we're going to do something even simpler than what we did before. Is we're not even going to use this fold. We're actually going to use a built-in function called unwords, I believe it is, which takes a list of strings and turns into a string, putting a space between each of the things. So now, if we do unwords instead of our concatenative fold, okay, let's look. What does the string look like? Aha! That looks correct. So let's try this now. yeah, it seems to be working fine. Okay. I don't know why we're so cranky. But yeah, if we say, you can see it's a pattern of strings. And so yeah, I don't know. Was that worth figuring out? I don't know. Probably. It's probably a trick I'll use. Because it's one of those things, right? Like, so last time I was talking about how I often feel frustrated that like I end up relying so much on randomization that I rely so much on randomization that I don't like do interesting deterministic things. And this is actually deterministic, right? Like, this is not giving me randomized beats, but it is giving me something that's complex. And we can use it for a whole bunch of things. So pretty much all of the stuff we were doing before. The only problem is that we do have to write a remapping function every time. And it would probably be really nice to just have write an actual Lindemeyer helper that does all of that for us. And so maybe writing that will be what we end up doing next time. But till then, at least this was kind of a fun little experiment. Let me know if watching someone actually do like Haskell programming like this is more or less interesting than watching someone just live code, because this is the kind of thing that, I mean, I was a Haskell programmer for many years before I was a like Tidal musician, and so I always feel good when I get a chance to really like dig into things like this a little more, a little harder. But yeah, so until tomorrow night, because at this point I think I'm starting to feel comfortable that I'm going to do this every night. So until tomorrow night, I hope you get a chance to play around with Tidal and have some fun and mess around with live coding. Take care.